Last episode we launched goroutines. But goroutines running in isolation aren't very useful. They need to cooperate, share data, and signal each other. That's what channels are for. A channel is a typed conduit. One goroutine puts a value in, another takes it out. The channel handles all the synchronization automatically, which is the key insight. Channels are not just data pipes, they're synchronization primitives. And select lets you listen on multiple channels at once, the Go equivalent of event-driven I/O, but expressed in a few lines of straightforward code. A channel is created with make 3 operations: send, receive, close. Channels are typed, you can't send a string to a chon int. The compiler catches it. The synchronization guarantee. On an unbuffered channel, the send blocks until a receiver is ready, and the receive blocks until a sender is ready. They meet in the middle, transfer the value, and both continue. This is Go's model of safe data transfer. Instead of 2 goroutines both touching shared memory, one hands a value to the other through a channel. No locks needed. Unbuffered channels are synchronous. Send and receive happen at the same instant, like 2 people passing a baton. Both hands must be ready. The output will always be sender blocks first or receiver blocks first. They synchronize, transfer happens, both continue. This guaranteed rendezvous is what makes unbuffered channels ideal for signaling and tightly coupled producer-consumer pairs. Buffered channels have a queue. The sender doesn't block as long as there's room in the buffer. The receiver doesn't block as long as the buffer has values. Buffered channels decouple the producer and consumer in time. The producer can burst ahead as long as the buffer has capacity. This is useful when work arrives in bursts, or when you don't want the producer to wait for each item to be consumed. Choosing between them, unbuffered, when both sides must synchronize on each transfer buffered. When you want to absorb bursts or decouple rates, a common mistake. Using a large buffer to hide synchronization problems. If you find yourself tuning the buffer size to make tests pass, that's usually a sign of a design issue. Channels can be declared as send-only or receive-only in function signatures. This is purely a compile time constraint. You pass a regular bidirectional channel and the type system narrows it at the function boundary. The value is documentation and safety. If producer tries to receive from out, the compiler errors. If consumer tries to send to in, the compiler errors. The standard pattern for a pipeline stage. The function owns the channel internally, bidirectional, exposes only a read end to the caller. The caller cannot accidentally send into it or close it. This ownership model, sender closes, receiver reads, is the idiomatic Go pattern. Rule: only the sender should close a channel. Closing from the receiver side causes a panic. Closing an already closed channel causes a panic. Receiving from a closed channel immediately returns the 0 value plus false for the OK flag. No panic. For range over, a channel receives values until the channel is closed. This is the idiomatic way to consume a stream of values from a channel. Without close, the loop blocks forever. The pattern is sender defers close, ch, at the top, receiver uses for range. The 2-value receive gives you fine-grained control when needed. OK is false when the channel is closed and empty. It's true when a real value was received. This is useful when you need to take different action on close versus receive, or when you can't use range, e.g. you're also checking another channel in a select. Multiple receivers, one channel. When multiple goroutines range over the same channel, each value goes to exactly one receiver. Work distributes automatically. This is the basis of the worker pool pattern. Select lets a goroutine wait on multiple channels simultaneously. Select evaluates all cases, checks which channels are ready, and picks one. If multiple channels are ready simultaneously, it picks one at random. This prevents starvation where a busy channel perpetually starves a quiet one. If no channel is ready and there's no default, select blocks until one becomes ready. Timeouts with time. After. The most common select pattern, time. After D returns a chon time. Time that receives a value after duration D. Put it in a select case and you get a timeout that fires if the channel doesn't respond in time. This is how Go programs avoid hanging forever on I/O. Non-blocking operations with default. Adding a default case makes select non-blocking. If no channel is ready, default runs immediately. Non-blocking receive lets you poll a channel without commitment. Useful for checking a cancellation signal without being forced to stop. Cancellation pattern with done channel. A common pattern for stopping a goroutine. The worker handles jobs or exits, whichever happens first. The caller sends to or closes done to signal the worker to stop. This is the pattern that avoids goroutine leaks. Loop plus select for event-driven logic. This is Go's approach to an event loop, readable, exhaustive, composable. A common pattern. Merge multiple input channels into a single output. Each input feeds into the output. The consumer reads from one place. Each input channel gets its own goroutine forwarding values. When all inputs are exhausted, the output is closed. The caller ranges over the merged output. This is the basis of Go pipelines. Transform filter aggregate stages, each connected by channels. Each stage is independent, testable, and composable. The select statement can also do this more directly for a fixed number of inputs. Setting a channel to nil after it closes is a useful trick. A nil channel in a select case is never ready, so it effectively disables that case without restructuring the code. Channels are typed, synchronized conduits between goroutines. Unbuffered channels synchronize sender and receiver at each transfer. Buffered channels decouple them with a queue. Chan is send-only. Chan is receive-only. Use these in function signatures to make data flow explicit and catch misuse at compile time. Only the sender closes. For range reads until close. To-value receive v. OK. Equals. Ch lets you detect close. Select waits on multiple channels simultaneously. Random selection when multiple are ready prevents starvation. Time. After gives you timeouts. Default makes it non-blocking. A nil channel in select is never selected. Use this to disable cases dynamically. Fan-in merges multiple channels into one. It's the building block of Go pipelines. Next episode, the sync package, mutex, RW mutex, wait group, and once for the cases where shared memory is the right tool after all. This course is based on the complete guide to Go programming. Available on Apple Books and Amazon. Find it at pixelstech.net/book. See you in episode 15.